How is it possible that one single calendar date could connect brilliant people and their world-changing ideas across hundreds and hundreds of years? Well, today we're going to dive into one of the most remarkable dates in the entire history of science and math. April 17th. I know, it seems like just another day on the calendar, right? But hold on. What if I told you that this one specific date is a crossroads, a meeting point for some of the most amazing minds who completely changed how we see the world? The real question is, why?
Think about it. On this single day, April 17th, spanning different centuries, different continents, these incredible thinkers were either born or they died, and they left behind ideas that are still shaping our lives today. So let's meet our first one.
Okay, let's kick things off with a mystery that's happening deep inside our own planet.
So when an earthquake strikes, scientists can actually tell that some waves are moving the ground horizontally, kind of slithering side to side like a snake. But how in the world did we first discover these invisible sideways moving waves?
The answer takes us right back to our date, April 17th, 1863, and the birth of a man with, I think, the absolute perfect name for this story, Augustus Love.
And here is how our mystery gets solved. Augustus Love discovered this totally unique type of seismic wave that literally shakes the ground from side to side. And here's the cool part. These love waves travel only through the Earth's crust. This gives scientists an incredibly powerful tool because by measuring them, they can figure out just how thick our planet's outer layer really is. So he didn't just find a new kind of wiggle in the ground. No, he gave us a way to read the story that's written in the Earth's crust. He totally changed how we understand the very ground beneath our feet. And there he is, our first pin on the timeline. One date, so many amazing stories. Let's get ready for our next stop on April 17th, but this time we're going to jump way, way back. All right, from the depths of the Earth, let's turn our gaze up to the sky. I mean, really think about this for a second. Long before we had space travel, way before we had these powerful modern telescopes, how could anyone possibly create a detailed map of another world? Who was the first person to look up at the moon and just decide, you know what, I'm going to chart that? The answer goes all the way back to April 17th, 1598, with the birth of an Italian astronomer and priest named Giovanni Riccioli. So Riccioli put together this absolute monster of a book, a huge encyclopedia of astronomy. And tucked inside, he included some of the very first detailed maps of the moon. But here's his most incredible legacy. He created this system of naming things on the moon after famous scientists. You know, craters like Copernicus, Kepler, Galileo. That was all his idea, and it's the exact same system we still use today.
He obviously couldn't travel to the moon, so he did the next best thing. He brought the moon to the world. Every single time we look at a modern lunar map, we're still seeing its features through his eyes, using the names that he chose all those centuries ago.
So let's add him to our April 17th timeline. We've seen the Earth and we've seen the sky. Now let's explore a world that's made of pure numbers. This next person is someone you've definitely heard of, but maybe not for this reason. Can you actually take a simple grid and fill it up with numbers in such a perfect, elegant way that it almost seems to defy logic, as if there are hidden patterns everywhere you look? The brilliant mind behind this piece of mathematical magic belonged to none other than Benjamin Franklin. And our connection? Yep, April 17th, 1790, the day he passed away. This right here is one of Franklin's incredible magic squares. It's just wild. Not only does every single row and every single column add up to the same number, 260, but so do the half rows and the half columns. It's just packed with these hidden symmetrical patterns, a mathematical puzzle he created simply for the fun of it. Franklin famously said, man is a tool-making animal. He applied that idea to everything, even creating these intricate tools for the mind, like this magic square, built from literally nothing but numbers on a page. Okay, let's place him on our timeline. We have one more stop on our journey through April 17th, and this one deals with one of the most powerful ideas in all of modern thinking. Let's tackle a really big question now. Okay, think about this. You have a belief about something, but then you get a new piece of information. How do you, mathematically, logically, update your belief to be more accurate? How do we learn from experience in a structured way? For that, we turn to Thomas Bayes. He was a quiet minister and a brilliant mathematician who died on, you guessed it,
April 17th, 1761. And the wildest part is his most famous work wasn't even published until after he was gone.
At the heart of it all is his famous Bayes' theorem. It's basically a mathematical formula for updating a belief when you get new evidence. This single idea is the engine that powers so much of our modern world, from your email spam filter to medical diagnostic tools. In essence, Bayes gave us a formula for rational learning. It's a precise way to measure how we should adjust our thinking based on what we observe out in the world. It turns uncertainty into better and better guesses. So we've met an earth shaker, a moon mapper, a number magician, and a probability pioneer. What's the hidden thread that ties all of them together? They lived in completely different centuries. They studied wildly different things. But Augustus Love, Giovanni Riccioli, Benjamin Franklin, and Thomas Bayes, all of them connected by April 17th, were united by one powerful, fundamental question. What is the hidden pattern here?
They looked for the underlying structure in earthquakes, on the face of the moon, inside a grid of numbers, and even in the very way we think. Their hunt for patterns changed the world. So that leaves us with just one final question. What hidden patterns will you look for?